Right. I start the session a bit late, but everyone, thank you for keeping the patience. A very good evening. Thank you for joining on a Sunday evening for this masterclass. So today's masterclass, we have Smriti with us, and today's topic is around machine learning and all about the world of data, machine learning, AI, and the likes, right? So definitely, this masterclass is a part of our Coders Bootcamp, which is starting on 24th of October. One of the pathways is machine learning, and for the same, Smriti has joined us to help you understand exactly what it is, what are the possible careers, and what all is really involved in it, right? So I think I would like to introduce Smriti a bit. So Smriti is the head of AI at Earthbanc, which is a Swedish company, and she's not only leading Earthbanc, but she's also the ambassador at Google Women Techmakers, and she's definitely passionate about technology, about environment, about sustainability, and she gives a lot of talks and speeches to promote AI in the industry for towards sustainability and much more. So at MyWays, we are very proud to have Smriti on board with us, and I'm sure the next few minutes you will learn a lot about what we have prepared for you, definitely. And please feel free to drop in your questions in the chat box. We'll be happy to take all of them at the end of the session. Welcome, Smriti. Good evening.
Thank you for the introduction, and I hope you're doing well. And I'm
Right.
excited for the sessions. So I will present my screen and I will turn my camera off because I have some Wi-Fi problems today.
Yeah, so just to let everyone know, we are facing a little bit of technical difficulties today, but I hope you keep the patience. Definitely, Smriti has not been keeping well, and she did not want to postpone or shift the timing of the session. So we decided to still go for it. So I would request all the patience, and we'll definitely help. We'll take any doubts that you have. Right, over to Smriti.
So I will start sharing my screen in a second. Okay, so as you know that this bootcamp is Introduction to Machine Learning 101, so I did not think of a creative name and I just stuck with that. So what is machine learning? Oh, okay, I thought I would introduce myself a little, but then we already did, so we'll just go to what is machine learning. Yeah, so how are Amazon's robots able to do what they do? They use machine learning, which is often an algorithm that is coded by hand and is a zero learning algorithm. So when it receives input, it always responds in the exact same way without learning anything. So machine learning is a system of algorithms that receives inputs, produces outputs, and then checks the inputs and adjusts the system's original algorithms in order to produce even better outputs. So one type of machine learning, for example, is anomaly detection, which looks for events that vary significantly from the majority of data. So anomaly detection, for example, is employed by Stripe to detect any sort of fraud or any suspicious transactions, etc. H&M deciding how many clothes to produce and how to change the order of arrangement in a store. Truecaller categorizing your calls into spam and sending you a notification before you could even answer. It's all machine learning. So I can give you an example of an organization called Crisis Text Line, which uses machine learning to figure out which words, when typed in a text message, are more likely to predict suicide. So to isolate words, it employs machine learning technique called entity extraction. Then it uses natural language processing and sentiment analysis to figure out the words ibuprofen, which is 14 times more likely to predict suicide than the actual word suicide, and that the crying face emoji is 11 times more likely to predict that a person is in crisis. So, the more complicated the problem we attempt to solve with machine learning, the more sophisticated the algorithms become. So, consider computer vision and the effort to identify a red ball. So, the ball is a simple shape and that's easy to recognize and label correctly. However, if the ball is placed next to a mirror, it stops looking like a ball. If we dim the light and put a small plant in front of the ball, obscuring its features, recognizing the shape becomes extremely difficult. So, a solution to this problem is a technique called representation learning, which means that we break the red ball into its component features, the things that represent a ball that is red, in essence of learning features, extracting high level abstract features of the red ball. It can be the curvature, relative size, and color. But just as the small plant in the mirror and the dimmed light make recognizing the labels of the ball difficult, the real world can obscure features and pieces of data that our machine learning models are able to observe. So here in the next slide, in this slide, um, you can see some of the things that machine learning can do, as written by Andrew Ng, who's one of the modern pioneers of artificial intelligence. So this is a simple way to actually understand and think about supervised learning. Most of them are pretty binary, and it's actually simple to understand. So if you want, you can take a minute here, and if you have any questions, you can leave it in the chat. And after a minute, I'll proceed to the next section. So what I'll talk next about is data science, machine learning, and artificial intelligence, the correlation and the importance. So this would be relevant for anyone who's trying to get into the field or who's like a beginner in artificial intelligence. Let's say a programmer or an analyst who wants to brush up their knowledge of key terms and understand them better. So moving on. There's a lot of overlap between artificial intelligence and data science. We'll dive into what artificial intelligence comprises of in a bit. But overall, there's like huge overlap. And one of the main reasons for this overlap is that in one way or the other, all of it deals with data, and it's like massive amounts of data. So I will talk a bit about artificial intelligence and then give some real life examples of how some companies use these things for their work. So this image here is the taxonomy of AI. So basically, artificial intelligence has been around since at least the 1950s, but it's only been in the past few years that it's become so popular in a way. So companies we interact with every day, Amazon, Facebook, Google, they have fully embraced artificial intelligence. It powers product recommendations, maps, our social media feeds. But it's not only the tech giants that employ artificial intelligence in their products, even startups, which I've worked with a few on climate change, healthcare prediction. I worked with banks. There's a bank called Swedbank in Sweden, so we have worked with them. Consulting companies, Accenture is a huge example, and even governments and are integrating artificial intelligence solutions. So simply put, artificial intelligence describes a machine that mimics human behavior in some way or the other. So artificial intelligence can make the user experience similar to interacting with a human. The human part is the output and huge amount of data that is the input. That's what allows artificial intelligence to learn and adapt. It takes in reams of information and data and processes it. If it encounters a problem, it learns from the situation and then recognizes a pattern. There are different terms being used, sometimes interchangeably, sometimes incorrectly, to describe artificial intelligence. But overall, it's an umbrella which comprises of a lot of different things, a lot of different forms of learning. The main buckets here are obviously machine learning, deep learning, and neural networks. So we have already discussed machine learning, and then after machine learning, like if you advance it further, there are brain-inspired learnings, which is again a huge subcategory here is neural network, and then deep learning, which where the model can learn itself, and there are several different methods for that as well. Also, there's spiking neural networks. I worked with spiking neural networks when I was doing my bachelor thesis at KTH Royal Institute of Technology in Stockholm, and I like the main part of my thesis was to study human brain and how people lose memory and inside, you know, inside the brain when in diseases like amnesia and dementia. So I used this algorithm called Bayesian confidence propagation neural network and sequence learning in a non-spiking attractor neural network atmosphere. But I also did some experiments with spiking neural network, and I analyzed the behavior of non-orthogonal sequences in the human brain and how it's represented, etc. So our research presented that proposed neural network can encode and reproduce certain temporal aspects of the input, and it offers internal control, and like it can basically, if you feed a sequence to the human brain, it is capable of spitting it out in the same way, and there can be certain modifications as well, and it can remember in most cases. So again, I was talking about why there's an overlap, and that it is because there's massive amounts of data. So maybe we can take a quick look at a company that makes lawyers' lives easier by making them infinitely better at their jobs. So this is a company called Everlaw, which developed a technology that looks through case law during the discovery and process to find documents that are relevant and important to use in a certain case. So they help law firms, government agencies, corporations sift through millions of documents in a big lawsuit and investigations to find, like the needle in the haystack. So how are they able to do it? By creating and maintaining data pipelines and data analytics, storage and reporting, and deriving insights from various data sources using statistical methods and machine learning models. Data scientists help machine learning engineers design and build better ML algorithms and use ML techniques and assist developers in implementing new AI features. So, for example, the role of a data scientist at Everlawyer is a great example of what the job entails at a fundamental level. In essence, a data scientist looks for new data sources, creates pipelines for their data, designs dashboards that make sense out of the data, and ML engineers help build better algorithms. Another example of what data scientists do is at the job at Airbnb. I can give, for example, where there's this awesome person who works, Zach Wilson, and if you want to learn about data engineering and software engineering, he's the person to go to. So role is heavily focused on analytics and building data pipelines that help inform business decisions. They figure out what metrics are most important for the organization today and analyze them in the right way. On the other hand, machine learning engineers build and maintain scalable ML algorithms that are based on core computer science concepts like data structures, algorithms, profiling, optimization, etc. Machine learning engineers code more than data scientists, and data scientists make sense out of the data that drives the business forward. So that's a key difference, in my opinion, or based on what I've seen. So next, I can talk about roadmap. I can type the answer in the chat. I spoke about Everlaw and I spelled Airbnb wrong. Everlaw and Airbnb. So next is roadmap in AI, data science, and machine learning. So in the past, a machine learning engineer was typically a software engineer with some knowledge of machine learning concepts. But in today's world, a machine learning engineer is a software engineer who does not only understand the latest machine learning and deep learning concepts, but is also able to deploy an AI system in production that is highly reliable, fast, and scalable. So if you take a look at the leading job sites, you'll find that many hiring companies prefer individuals who possess a master's or a doctoral degree in mathematics or computer science. But I don't have either. And in my experience, and also what I've seen again, experience trumps education in these cases. So obviously, strong technical skills are required for everyone pursuing a career as a machine learning engineer. A software engineering background is a very amazing place to start here, especially a background with large code bases that achieve scale in the real world. Some of the most sought after skills in machine learning are expertise in Python, C, C++, development, excellent algorithm and data structure skills, and like an ability to quickly learn and modify large code bases. So from there, a solid understanding of statistics, statistical modeling, and machine learning is extremely important. Statistics is all about collection, organization, analysis, and interpretation of data. Statistical models, at their most fundamental, are mathematical models that incorporate statistical assumptions about the generation of sample data. In other words, they represent the data generating process used in the sample data analysis. For example, establishing a relationship between two variables that can predict a proper outcome. Things like average height of men and women age 40 in Iceland. I want to go with Iceland because I want to go there and I haven't visited still. Statistical modeling typically has identified unknown parameters that are usually interpretable and important. Measuring everyone's height in Iceland is impossible. Using a sample from the population is possible. So we have to understand those things. In contrast, machine learning models usually do not attempt to isolate the efforts of any single variable. Machine learning does not model the data generating process. It attempts to learn from the data sets that's already made available to it. So some of the skills that's needed for, I would focus more on machine learning engineering, as that's the whole that's the topic of the seminar. But these are obviously important for AI and other AI positions and data science roles as well. So a foundation in computer science really comes handy. Machine learning deals with vast amounts of data to build maximally performant data pipelines that can handle terabytes or petabytes of data. You need to understand how machine learning algorithms work and the space and time they take to process data. That's extremely important. The other thing that, in my opinion, is one of the most important things, especially for someone who's interested in data science, is math and statistics. So you'll have to understand mathematics to process and structure the data you're dealing with. Exactly how much and what kind depends on specifics of your role. But it's safe to say that a typical machine learning engineer or a data scientist will have familiarity with linear algebra, calculus, probability theory, and descriptive statistics. Next is programming. Since I used Python, for me it would be Python and libraries, but again, it can be any language. So I personally use Python as it is the foundation of most data science and data engineering frameworks, and it's versatile, has a clear syntax, and can be used in different programming paradigms from object-oriented to functional programming, and comes with a lot of libraries which come handy and help with writing software for different functions. Another thing would be data storage and pipelines, which I think is extremely important. An understanding of how to operate with SQL and NoSQL databases is a necessary skill required for building data pipelines. For example, Spotify's Liugi framework helps developers deal with low-level plumbing for data so that they can focus on high-level strategies for what their machine learning needs to actually do. Next is data wrangling, the most important part, because if you work with real life problems, you spend 80% of the time finding the data, cleaning the data, and that's extremely important. So for data to be used by machine learning algorithms, it often has to be cleaned up. The process involves removing mistaken values, validating the data, and then manipulating it to a desired state so that it can be transformed or handled elegantly by algorithms, by several different algorithms. One popular data wrangling library in Python, for example, is pandas. And like mastering that would go a long way. Machine learning theory. This is pretty self-explanatory. If working with Python, a good place to start learning is a Python ML module called scikit-learn. And then GitHub, collaborative learning, Docker, APIs. So since most times you'll be working in a team, learning how to use Git for version control and GitHub for collaborating with other developers is critical knowledge. It also helps to master a code editor that makes working with Git and GitHub easier. Docker is a tool that helps developer build and deploy distributed applications. It is yet another essential development collaboration tool, and I think it's extremely important to learn it. Then machine learning and deep learning algorithms and architectures. So basically, machine learning algorithms fall into three categories: supervised, unsupervised, and semi-supervised learning. So in supervised learning, the input has a corresponding output data. One example is images of red balls obscured by objects. We know that there is a red ball, and machine learning algorithms are trained to recognize the ball regardless of how obscured that is. Unsupervised learning has input data, but it does not have a corresponding output data. Its goal is to model the underlying structure or distribution in the data in order to learn more about it. Semi-supervised is a combination of both, where there are lots of inputs, but only a few corresponding outputs. Deep learning architectures like convolutional neural networks, recurrent neural networks, recursive neural networks, they're also extremely important. CNN finds really good applications in object detection. I work with CNNs personally to predict the amount of carbon that's been sequestered in a biodiversity, for example. There are other things that may be necessary based on the role that you may be interested in. Big data processing, frameworks, and distributed computing could be some. So I also wanted to talk about jobs or job profiles. So there are many different roles within these industries, such as, first, engineering and development. In engineering and development, most commonly a machine learning engineer, that's a role. So in that you handle bulk of coding applications, you create systems that move data and implement algorithms designed by data scientists. Second is data science. In data science, you could be a data scientist or a data analyst. The job is to design machine learning models that create distinctions in data. Business intelligence, You help with query and present business implications, typically from data-driven insights. Then there's research. So while the other roles tend to be more applied, a research scientist is typically pushing the boundaries of artificial intelligence through new discoveries rather than applying existing problems and models. There's a lot of work going on in AI ethics right now, which is also extremely interesting. Then there's product. So finally, there are roles like a machine learning product manager or product lead. This person brings together tech, business, and design in order to create a product. They're often responsible for facilitating the project development or the product development agenda and even managing profit and loss of a project. Right? So you have a model, for example, which works with 100, like not 100, 99% accuracy. You're very happy about it, but then you have to consider the cost of production, etc. So that could be something that comes under this role. So industries often focus on different areas of knowledge and have specific needs, language, and data types. For example, a software company will be focused on different metrics than a banking company. One of the key methods to keep in mind is code switching, which is not a reference to computer programming, but the language and key terms that you express yourself in. Different industries have a different jargon, and often using it can help you converse properly and find a role at the company. Specifically, it can help you pass screening tests for interviews. Also, if you're looking for looking to get into a certain industry, you'll have to optimize your resume, LinkedIn profile with keywords that are more common in that industry. It's important for screening purposes as well. Also, according to LinkedIn's Emerging Jobs report, the largest hiring industries for machine learning, artificial intelligence, and data science are software, higher education, and consulting or finance companies. It turns out that these industries often pay the most for machine learning talents as well. Different industries also focus on certain types of roles. For example, software, medicine, and telecom industries are typically the largest employers of data scientists. On the other hand, aerospace, information technology companies, they hire more engineers. And analysts tend to be hired by healthcare as well as consulting and banking companies. So there's some ground study that needs to be done, and it's important to be aware of the industry your potential employers will be in, so that you can learn more about their needs and how do they express themselves. So the last thing I want to discuss is life cycle of a data scientist. So, when a non-technical client or stakeholder asks you to solve a problem, the description of your task can be quite ambiguous at first. It's up to you as a data scientist or a machine learning engineer, artificial intelligence engineer, to translate the task into concrete problems and figure out how to solve it and present the solution back to all the stakeholders or a non-technical client or your managers. So the first thing is to frame the problem, understanding who your client is, what's the end goal, why are you solving this problem, what's the motive. And always having this customer first mentality helps understanding the end person it should reach to, or who you are building the product for. How can you translate this ambiguous request into a concrete, well-defined problem? It's important to understand and think about those things. The next is collecting the raw data that's needed to solve a problem. So, is the data really readily available? And if so, what parts of the data are useful? Because often when you receive raw data, it will contain a lot of mistakes, repetitions, a lot of things that have to be, taken care of. And if you don't have the data, what sort of data would you need? That's also an important thing to keep in mind. For example, when I work at Earthbanc right now, we send out some Google Forms to the customers to fill out, and also in which format would we need the data. Like if we work with satellite images, the satellite images have to be in .tiff format, for example. If it's PNG or JPEG, then it's not really useful for us. So understanding those things, and what other information would we need from them. I worked on a medical case with a company called Catalyson and Partners in Sweden, and we worked with some senior MDs in Switzerland. The aim of the project was to predict if a person should be operated or not in a shoulder arthroplasty operation in order to save Switzerland government's money. So there we requested some MDs for the data. The data included like if a person's injuries in the dominant hand or not, their age, their gender, if they smoke, if they're diabetic, and the tendon size, the cut size, like those things. So it included several things. So we had to ask for those data. So it's important to spend some time on it, because if you don't have the right data, you can't really proceed further. Next is processing the data wrangling, as I mentioned earlier. So real raw data is rarely usable out of the box. There are errors in data collection, corrupt records, missing values, and many other challenges that you will have to manage. So you will need first to clean the data and convert it into a form that you can further analyze. I spent most of my work time in that project cleaning the data. So this was pretty funny, but when I got the data, it had almost 6,000 rows of information. And after cleaning the data, I ended up with 400. So you can imagine most of the data was really not usable, either empty or it was obviously not correct. So there are usually a lot of problems that need to be taken care of in this step. The next is exploring the data. So once you have cleaned the data, you have to understand the information contained within at a high level. What kinds of obvious trends and correlations do you see in the data? What are the high level characteristics? And are there any of them which is more significant than others? So those things are to be taken care of here. Next is perform in-depth analysis, machine learning, statistical models, algorithms. This step is usually the meat of the project, where you apply all your cutting-edge machinery of data analysis to unearth high-level insights and predictions. So, for example, in that project, we started with decision trees, and then we eventually ended up with convolutional neural networks, as it gave the best results. Also, another thing to note is that it's extremely important to not overcomplicate your project. Start with a baseline algorithm. Don't just always go to complex deep learning algorithms. It's important to do studies and compare algorithms, their cost, complexity, results, everything. The next is operationalize. So once you have completed your in-depth analysis, or you have like a model that's working on your data, also in like the previous step, you categorize the data. While you're doing your in-depth analysis, you have the test data, training data, validation sets. All this goes here. So now when you are done with that, you have to operationalize. So you come up with the results from the previous step. You create some technical documents, make sure that the notes, codes are all commented. And then now once you're done with implementing your model on the data that was provided to you, you try it in a real world environment where the data is a lot more worse than you could have imagined, and look for product constraints, if any, and optimize the model if needed, which most probably it would be. The next is, and the last step would be communicate the results of the analysis. So all the analysis and technical results that you come up with are of little value unless you can explain it to your stakeholders or the managers that know what they mean in a more comprehensible and compelling way, because they are the people who are actually going to sell it. So it's important to identify all the key findings and communicate with those people about it, and explaining, often presenting it to a non-technical colleagues. Also, they will help you determine if the results are a failure or success based on whatever the predefined criteria is. Um, Data storytelling is a critical part and also an underrated skill here, and it's important to build upon that and use it. So the project that we did, about that shoulder arthroplasty thing that I was talking about earlier, after I worked on the model, we had to speak, we had a meeting with those MDs and certain stakeholders of the projects who helped us understand if the results were good or not. They also later asked us to analyze some more methods, integrate, like CT scans or certain other things with it. So all that comes here. But that wasn't really my part, but it's also important to understand what happens to your model after, in my opinion. So that would be it from me. I can share the presentation and also the notes, like what I spoke about today, if that's useful, because I know it can be a lot when you hear it all of a sudden at once. So I can share that. And yeah, so maybe we can have some Q&As now.
Yes. Hi. Thank you so much for that session. I was really enjoying, even though not understanding, but I was really enjoying the examples that you were adding in between the topic. So really thank you for that. Right. We do have many questions. We also have pre-submitted questions by people who have registered and submitted their questions before joining us. Right. Before that, I would just like to inform everyone again that this is a part of our bootcamp, which is a free 8-week learning program starting on 24th of October. Machine learning is a pathway. We will learn, we will build projects, we will attend masterclasses, and we will do a lot more. So please join in. I will drop in the link in the chat box in a while. Right. So moving to the questions, I think I have a very basic question to start with. I think you covered it in your session also. So somebody is asking, what is the difference between data mining and machine learning? You are on mute.
Yeah. So the question is like difference between data mining and machine learning, right?
Yes.
So data mining is actually used on pre-existing data set. For example, a data warehouse where you already have like a lot of, like information, a lot of data, and then you use it to find patterns between those pre-existing data sets. While in machine learning, you like you train the model on that data set. So here you teach the computer how to make sense out of the data and then make predictions about new data sets that you will feed in later to the model or use later. So that would be a difference.
Okay. And we have one question from Jyotsana, who asks, so which is better, machine learning research field or machine learning application field?
That actually depends on the person, I would say. Like I personally like the application development field more because I somehow like coding nowadays. But it would be interesting for someone like machine learning research field is extremely important. And there are a lot of very interesting research work that's going on. I like to read about it sometimes, but I'm not a person who can like sit idle for a very long time. And, so it depends on the person. if you're interested in new things that's coming up, if you're interested in learning a lot of information and not very interested in coding, then that would be a really good field. Like there are very interesting research that's going on, AI and mental health, AI and ethics, different SDGs. So it's extremely interesting.
Right. So this is my question. So how come you got into machine learning and AI and data? So what was your journey like, and how were you exposed to this world? Maybe we can get a brief on your journey as well.
So I actually think that I basically sucked at everything else. So when I was in my first year of undergrad, I tried some internship on sensors. Then after that, I was involved in the launch of PySat. It was one of the first student satellites that was launched. So I was involved in that, and then there I was involved in attitude determination control system part of it. So understanding, like, why am I saying understanding so many times? When the satellite is launched, it has to be stable. So in order to stabilize it, you have to do a lot of things to it. So I was involved in that. There I worked on C, C++. I did not, I liked coding, but I did not like the application. Like it was good, but not something I could work on for a longer time. So then I wrote a paper on it and I went to Germany, to Bremen, to present it. And that's when I went to ETH Zurich and I attended a deep learning lecture. Also, that summer, I studied air pollution at IASC. I did an internship on that. So when I went to ETH Zurich and I attended that deep learning lecture, it was under the professor Ander Konukoglu. He is amazing. So I really liked it, and I was always like really intrigued by the human mind and chess. I really like chess, and deep learning is a lot like chess to me. So combining everything, I decided to apply for this find something in Europe based on that. So I had met a professor during the conference. So I emailed him and I just had like a Skype call with him or something. And then he had funds to partially fund my internship at KTH. So I went there and I studied computational neuroscience for 1.5 years. So that's how it was. And after that, I wanted to do my master's, but I did not get in. So I looked for a job. And then, yeah, but I did a mistake. I just applied to one university with 3% cutoff rate, and I shouldn't have. So,
Right.
so yeah, after that, I started working at Earthbanc as the head of artificial intelligence, where I initially was implementing similar algorithms from my research earlier at KTH, but now it's completely different. So yeah, that's how
Right.
it
I think
is.
everything happens for a reason, right? Maybe you were meant to join Earth Bank, and that is how things play out. Right. So I thank you for that detailed answer. We'll move on to some more questions from the audience. Right? Most of the time, so Rohit is asking, most of the time data sets are available, but what if we need to collect data and make a data set? Do you recommend any tools that are available to collect these data sets?
So it can be an extremely tedious process. As I said, collecting data and cleaning data takes 80% of your work time and energy when you're actually working on a machine learning model. So SQL is really good for it. You have to scrape the data from like various places. You can use pandas, beautiful soup, etc. also, but collecting real time data, etc. It's very important to learn SQL, and also some of the like data storage and pipelines to actually make use of it.
Okay. I hope Rohit that answered your question. So we have Sujit who's asking more of a career-oriented question. He's asking if a person having 2 years of experience in SQL, as you mentioned, and that person is doing some courses and upskilling, do you think what is the probability or what are the steps to get a job in India or out of India? Any recommendations? Any idea?
So I don't want to say this, but I wouldn't like it's nice to do courses, but no one really looks at your certificates when it comes to this. It has to be like more applied learning. Like for example, the boot camp or that you are going to do, it's going to be a lot of applications like coding. You get better. So that's important. Like doing actual applications. So when it comes to 2 years of experience, let's say. So if the person's interested in machine learning, data science, etc., it's important to know Python, at least like Python, in my opinion, or one object-oriented programming language. Python is the most used, or R would be good if it's data science. So it's important to know that. And I would suggest, along with the courses, to do like some projects. Having a good GitHub page will really help a lot if the person does not have a lot of working experience in it, because most companies, they ask to look for your GitHub page. And even if they don't, it's nice to share it with the application. And
Okay.
yeah, so it's extremely competitive. It's important to get someone to recommend you right now. Tailoring your resume, LinkedIn, it's extremely important. And after you get the after you get the interviews, I would say it won't, like, depending on the number of candidates, applicants, obviously, but you have a lot higher chance if you do things good. Like after that, the rounds are usually, the first round could be like a discussion with, like a semi-technical round where they get to understand you, and some technical skills like what projects have you done, what did you learn, what mistakes did you make, etc. Then there will be like a complete coding round or something like that, either a home task or you code in front of them. So that round is most critical in my opinion. So that's why I'm like emphasizing so much on experience. And then it'll be a technical interview, which I have not seen to be extremely difficult, and then HR. So yeah, I think that answers his question, or I might have gone off track. I don't know.
No, definitely. I do believe that even especially in technical fields, practice and hands-on approach is more, required in today's time. So we have a common phrase here at MyWays that employers often want experienced freshers. So they want experience, but it's okay if you're a fresher as long as you have some hands-on knowledge of what you're doing. Definitely.
Yeah.
Uh, right. Sujit, we hope we answered your question. Maybe you can tell us in the chat. I'll move on to the next question. I think we have time for maybe 2 to 3 more questions, right, Smriti? You have
Yeah.
that's okay. Yeah. Right. So with ML ops and AI ops coming in picture increasingly, what do you think is the future of AI?
So, in my opinion, it can be a controversial thing a little, but I know a lot of people think that it won't be good for that, but I think it will just create more opportunities and more, like it'll make our job easier and create more opportunities, so we don't have to like emphasize on like time taking, tedious tasks that often. But I know a lot of people think that it's gonna, like take over. But I don't believe in that. That can
Definitely.
take a lot of
So we
time
are
to answer.
often asked that, we are often asked maybe in emails and by students that is AI going to take over jobs? And our usual answer is that no, it is going to only add on jobs. It is going to only increase the opportunities in the industries. Yes, definitely. Right. So, uh, how do we how do we tackle or improve auto AIs, which are automated tools of building a model?
I actually have no experience in that, so I can't answer that. I can maybe
That's
do some
okay.
research and connect with the person if they want to connect with me on LinkedIn, or I can put them in touch with someone who knows about it. But I
Okay.
don't.
Okay. That's absolutely fine. Right. I think we can maybe add. So we share usually a summary of the session post the bootcamp masterclass. So maybe we can add the answer in the summary itself. right? Right. I think next is a general question. Having the right data knowledge is important, or having the right algorithm knowledge is more important?
So I think, I mean, ideally you need to have both, but based on what's your strong suit, you can decide if you want to go towards data science or machine learning. Like if you are better at building algorithms, then machine learning is a better career path. And if someone's like more good at crunching data, understanding insights from data, then data science. But ideally, you would need both for any position. Like even a data science builds algorithms, and a machine learning engineer works on data. So yeah.
Okay, right. Um, I, okay, somebody is asking, are there any uses of Python in web development? If yes, how so? I think it's a bit
So
beyond the scope, but I think we
yeah.
can take it. Yeah.
Um, I think that like in web development, in my opinion, I haven't worked on web development, but I know Python is used for a lot of data frames and a lot of like backend programming, etc. As well. There's Django, there are other things
Yeah.
that are used. So yeah, it's definitely useful, and I can maybe add some like real life examples and how some companies are using. I know YouTube uses a lot of like Python, Spotify uses a lot of Python, so they do use these things. So maybe we can add it in the summary, like some applications as well. But yeah,
Right.
it's definitely useful, especially in like the back end part. Front end, I don't think mostly people use it, but yeah, back end, a
Yeah.
lot of them do. Yeah,
Right. In software development, mainly to create
yeah.
programs and basically intelligent programs, I would say, where Python might be
And
required.
I still think a lot of people prefer Java in web development and JavaScript, but I think
Right.
I have some friends who use Python for it. So
Okay. Okay. Maybe we can add this too in this session. Yeah. Okay. I think this would be the last question. Do you think companies are looking more for data engineers or data scientists? As getting the right data is essentially more important for any project.
So companies need both. Any company that would need a data scientist, they would need a data engineer. So you need the data and you need to understand the data, but you also need to make sense of the data and then build infrastructure around the data to like deploy it and other things. So it's extremely like both the things are, like go hand in hand in my opinion. So it really depends on what you are more interested in. Like if you're more interested in statistics analysis, um, algorithms like AIML algorithms, and not that much in coding, then data science would be a better fit. Otherwise, like data engineers, they code a lot more than data scientists. Data engineering is more close to software engineering.
Right.
So that's the both are like anyone, any organization, if they have data scientists, they'll have almost equal number of data engineers.
Right. Okay. We today have talked about so many fields within ML, within AI, right? In the scope. So how does one who is so we do have a lot of beginners, as I asked in the poll. How does one really, decide what would maybe eliminate choices, or what would they really like to do, or how does one really decide what to pursue? Right? Maybe once I decide, then I can excel in it. But how do I really decide? What would be your tips? Yeah.
So as I said, like it really depends on, like what you enjoy the most. For example, if you are someone who really wants to make sense out of the data, for example, like I do that. I really like to understand data, you know, um, scrape data, get my hands dirty. So if it's that, then I think data science, like data analyst or data science, is like a better role. If someone's like completely into likes coding a lot, then there's machine learning, data engineering, AI engineering, those things like which involves some sort of deployment of models, building infrastructures around it. and all that. Then there are people who are interested in, like, semi-technical ish roles. There are product managers who do that. They understand the model, help with the development, and then they go to webinars, seminars, explain it. There are also, like, for example, I was speaking to someone from MatWorks a few days back, and he said that they have some roles which is like technical selling. So those people, they help with building models, and then they talk to customers about how they can make it better. So there's AI even in sales now. So it actually depends on what the person's interest would be. And there are like key points, as I mentioned right now, that are like most predominant feature in one. So based on that, it's easier to eliminate. And there's a really nice video by Cassie. What's her full name? Okay, so she's, I think, the head of data scientist in Google. So she has a very nice video, like, on if the person, like, if someone should become a data scientist or what field to choose. So there are some videos as well out there that maybe we can attach as well with the summary if that's helpful.
Yes. Yeah.
But yeah, based on these things, it's easier to understand what field someone's good at or want to pursue.
Right, right. Thank you, Smriti. Uh, I think we have we have one last question. I think I am a remote sensing MTech student. Can I know about your role as Earthbanc is related to my field?
So yeah, so what we do is, we how much time do we have?
I think maybe 2 to 3 minutes before I just
Okay.
wrap it up. Hmm.
So what we do is, we actually, I'm not going to dive into the backstory, but we get satellite images from European Space Agency, and we have a partnership with them. So once we get the satellite images, we analyze like different bands, like out of the 13 bands in the satellite images, we either understand, like, analyze the NDVI index, EXGI index, or panchromatic, and then we map or mask different layers on top of each other to detect objects. In this case, trees, for example. So we get a count of trees, and then we either use LiDAR data or digital elevation model data, all that, to get like the 3D information, the non-spatial information, like the height, girth of trees, etc. And then we can actually analyze how much carbon is being sequestered. We also check for forest fires, etc. So it's a combination of remote sensing, GIS, and AI right now.
That's really interesting work that your organization is doing. I'm really I'm used to it. That definitely. Sipna, I would also recommend maybe you can connect with Smriti on LinkedIn and get to know more if you want to know deeper into her work with Earthbank, right? I think yes. With that, I would like to thank everyone for joining in today, for asking questions, for keeping it engaging. I have mentioned the link of the bootcamp in the session. We will be starting with uh, exploratory data analysis. We will be doing unsupervised ML, supervised ML, optimizing model, a lot of things. You can check out the website. We will be also building projects. Sure, just give me a minute. I will drop Smriti's LinkedIn also in the chat box. Yes. So, oh, she has done that. Yeah. Yes. So you can connect with Smriti on LinkedIn. We will definitely be sharing a summary of today's session with you via email. If you have not registered for the bootcamp, you can write to us. I have also dropped in the email ID MyWays uses. Thank you so much, Smriti, for joining in. Even in we made it somehow after all the technical difficulties and the few hiccups. Thank you so much for enlightening everyone and for answering the questions so patiently. And thank you to everyone who joined in. Smriti, would you like to say any closing words?
All I can say is that this bootcamp sounds really interesting, and anyone who wants to, like, get some real life hands-on experience maybe should consider it. And yeah, and if anyone wants to connect with me and like have any questions on LinkedIn or something that I couldn't answer today, I would be happy to take it on LinkedIn or connect you with someone who can help you. So, yeah.
Okay. Thank you so much. Thank you everyone for joining. Have a good remaining Sunday, and I hope you have great weeks ahead. Thank you so much.
Thank
Good
you.
night.
Thank you so much for inviting me.
Thank you, Smriti.